wanted to know about what goes into to making those games work. And what I was not going to do is to go into loads of massive complex equations and build realistic sim-style physics. I didn't want to bring in an existing physics engine or start reading people's blog posts or start, copying and pasting big chunks of code into the application. I wanted it to be really a learning exercise for myself. And as I mentioned, I wasn't going to take in an existing code sample for this. I wasn't going to build on Unity. Unity, the game development platform, actually has a lot of physics services built into it, its own physics engine. It's got things like wheel colliders that you can use. And I because the people who come to my workshops and that I present to are .NET developers, they want to be working in Visual Studio. Unity, although you can use Visual Studio, has a very different development environment. So I kind of wanted to keep people happy when they're actually working with the game. So this is what I did. I basically went in and I rewrote the physics engine without really thinking too much about what I was doing and without actually doing any planning. So the first thing was to get the car stationary on the track with no external forces acting on the car whatsoever. The second thing was collision detection. I wanted a realistic way where the actual car would collide with the track in a realistic way. Also, when you collided with a barrier, you should actually be pushed back onto the track. One thing I wanted to include that's not in the original game is jump physics. So I wanted to have a realistic way where you could actually jump, and when the actual car landed, it would, properly simulate the way that the car collided with the ground, and maybe put in some damage simulation, to actually get that to work correctly. So as you can see, all of the physics is going wrong here. The other thing was loops as well. There are loops in the game, and I wanted to get a realistic simulation of how the actual car travels around a loop with centrifugal force. Now watch the MPH on the car when we hit the Earth. The car actually gets to a speed of 44 times the speed of sound, some of the actual segments in this. Now, this was great fun. My daughter loved it.